All right, concentration of a solution. So concentration, again, it's of a solution, which we know a solution is a solute that is dissolved in a solvent. And then the concentration is just how much solute did we put in how much of a solvent. So we are comparing those amounts. When you are asked to calculate concentration, that's basically the same thing as being asked to calculate molarity. So those words are mathematically, anyway, sort of interchangeable. Or at least they mean the same thing. Concentration we usually show with like brackets around the unit, around the substance, whatever it is, or molarity we usually use a capital M for, which I think you'll see in a little bit. All right, so molarity. The units for molarity are moles of solute over liters of solution. That's important because sometimes you won't be given a volume of a solution. You might be given information for a solute and a solvent, and you have to add them together to get the solution. So that's what you see here is if you're given information for a solute and a solvent, you might have to do some conversions and then add together to get the solution. So it is moles of solute over liters of solution. So it's also important in calculations to make sure you know which is which. We can express the concentration with these brackets, or we can express it by putting the capital M and then the compound. So if like your answer was 5, if you had a concentration that was 5 molar of NaCl, you could do like the number 5 and then the brackets and then NaCl, or you could do 5 capital M and then NaCl. Okay, so here are the units in a nice little like condensed format. So capital M is molarity, and it equals moles per liter, moles of solute, liters of solution. So here's an example in calculating molarity. You don't typically see calculating molarity. Usually we use molarity or concentration as a conversion factor. But if you were going to calculate molarity, it says, what is the molarity of a solution formed from 6.75 grams of dissolved or of NaCl dissolved in water? So dissolved NaCl dissolved in water. That makes NaCl the solute and water the solvent. And then it says to make a solution with a total volume of 452 milliliters. So again, remember we're moles of solute, so that grams is going to go on the top, and then over liters of solution, so that 452 milliliters goes on the bottom. So we're going to convert our grams to moles and our milliliters to liters. So first, grams to moles, we use molar mass to get from 6.75 grams of NaCl to our 1 mole. We use the molar mass. And then we're going to calculate the bottom as well. So milliliters into liters by multiplying by 1,000. And we get our answer, 0.256 moles per liter, or you could write 0.256 capital M and then NaCl, or you could write 0.256 NaCl and put the NaCl in brackets. This is how we would use it as a conversion factor, not necessarily calculating molarity. So it says how many grams of solute are in 68 milliliters of 0.0335 molar potassium hydroxide. So I'm starting with my volume. That was my given, right? This is a conversion factor because even though it has the capital M, we know in our brains that that's 2 units there. That's moles per liter. So I know that that can be used as a conversion factor. The same way we use density as a conversion factor. We're using molarity here. So my given is the 68 milliliters. So 68.0 milliliters of potassium hydroxide. I'm going to convert that to liters because I know that my molarity is over liters, not over milliliters. So I need to convert it to liters. Then I can use my molarity as a conversion factor. And then because it asked for grams, not moles, I'm going to convert my moles to grams using molar mass. So milliliters cancel, liters cancel, moles cancel. I'm left with my grams and I get my final answer, 0.1278 grams of potassium hydroxide. You guys need to put the 0 there. Unfortunately, this person did not. You will see more examples in your notebook for the molarity calculations.